Hey guys, my name is Reno, and today I'm going to be teaching you about proving statements about segments and angles. Alright, so first off, this is a new topic that we're going to be learning today. It's writing two-column proofs. So in the last lesson, or the last video that I uploaded, we learned all about writing with the equation, the statement, and the reasoning behind that. But today we're going to be looking at just writing the reasoning and then the statements. So to start off, a proof is a logical argument that uses deductive reasoning to show that a statement is true. A two-column proof has numbered statements and corresponding reasons that show an argument in a logical order. There are several formats for proofs. Today we're going to be looking at the two-column proofs, but in the next lesson we're going to be taking a look at flowchart proofs. So keep a lookout on that. So how a two-column proof looks. So left side has all the statements about some information, facts, equation are given, and the right side is the reasoning behind that statement. Alright, so this was the last question that we did in my last video. It was just about the light reflecting off and the angles given by that. So you're given that angle 1 is equal to angle 3, and you have to prove that angle DBA is equal to measure of angle EBC. So try to write a two-column proof for this. You're given something, so write all the statements that you would need to prove this and the reasoning behind that, and come back and I'll give you the right answer. Alright, so now that you're back, so first off, so statements and reasons, two columns. So we know that angle 1 is equal to angle 3, and that's the given information. Angle DBA is equal to angle 3 plus angle 2. That's the angle addition postulate. As you can see here, angle DBA is made up of angle 3 and angle 2, and angle EBC is made up of angle 2 and angle 1. So that's the angle addition postulate. Angle DBA is equal to angle 1 plus angle 2 now. Since we know that angle 1 is equal to angle 3, and angle 3 is equal to angle 1, so we can just substitute angle 1 for 3. That gives us angle 1 plus 2. That's a substitution property of equality. Next, angle EBC, as we saw, was equal to angle 1 plus angle 2. That's the angle addition postulate. And as you can see, they're both equal to the same thing. Angle DBA and angle EBC are both equal to the same thing, which tells us that angle DBA is equal to angle EBC through the transitive property. So that was an example of writing a two-column proofs. Now we're going to learn some properties of congruence. You're going to use this in future lessons to write proofs also. Alright, so reasons used in a proof can include definitions, properties, postulates, and theorems. So definitions, as we saw, angle addition postulates, the congruence definitions, and more. A theorem is a statement that can be proven. To prove a theorem, you could use two-column proofs. Just remember that. Once we have proven a theorem, we can use the theorems as reasons in other proofs. Alright, so some theorems. So first off, the properties of segment congruence. Segment congruence is reflexive, symmetric, and transitive. So reflexive, for any segment AB, AB is congruent to AB. Symmetric, if AB is congruent to CD, then CD is congruent to AB. If transitive, if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. The next set of theorems that we're going to be learning about is the angle congruences. And this is the same thing, reflexive, symmetric, and transitive. For reflexive, for any angle A is congruent to angle A. Symmetric, if angle A is congruent to angle B, then angle B is congruent to angle A. Transitive, if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. These all follow the same pattern, so this is going to be the same for even more that we learn. Alright, so now, naming properties of congruence. This is a practice that you guys can do. So, name the property that the statement illustrates. If angle T is congruent to angle V, and angle V is congruent to angle R, then angle T is congruent to angle R. If JL is congruent to YZ, then YZ is congruent to JL. Pause the video, give it a shot, and come back for the right answer. Alright, so now that you're back, So first off, that's a transitive property of angular congruence. We just learned it. Since angle T is congruent to angle V and angles V to congruent to angle R, we can substitute angle R for angle V here, which gives us angle T is congruent to angle R. And then here, that's just the symmetric property of segment congruence. We're just flipping YZ and J out. Okay, so proving a symmetric property of congruence. Write a two-column proof for the symmetric property of segment congruence. You're given that LM is congruent to NP. You have to prove that NP is congruent to LM. So we've just learned about we learned about the symmetric property of segment congruence. We've learned about what congruence means. So try to piece all of this together, write a two-column proof, come back for the right answer. Okay, so now that you're back, so first off, let's start by our statements and our reasons. So first off, LM is congruent to NP. That's our given. And then next, LM is equal to NP. That's a definition of congruent segments. If two segments are congruent, that means they're equal in length. And then NP is equal to LM. That's a symmetric property of equality. You're just flipping it, as we learned earlier. And then lastly, NP is congruent to LM. That's the definition of congruent statements. You're just flipping these. It's the same thing, but you're just flipping the order of these. So this should have been pretty easy, seeing as we just learned about this. But if it wasn't, give it another shot and see if you can do it. Okay, so lastly, prove this property of midpoints. If you know that M is a midpoint of AB, prove that AB is 2 times AM and AM is 1/2 of AB. You're given that M is a midpoint of AB, prove that AB is equal to 2AM, and AM is 1/2 of AB. Pause the video, give it a shot, come back for the right answer. Okay, so now that you're back, first off, let's get our columns here, our statements and reasons. So first off, M is a midpoint of AB, that's our given. Next, AM is congruent to MB, that's a definition of a midpoint. As we learned, the midpoint is in the middle of the segment, which means it creates two congruent segments. So that's what this says. AM is equal to MB, that's a definition of congruent segments. Congruent segments are equal in length. And then AM plus MB is equal to AB, that's a segment addition postulate that we learned. Next, AM plus AM is equal to AB, that's just substitution, as we know here. AM is equal to MB, so we're just plugging in AM for MB right here. And then when we add both of them up, we get 2AM is equal to AB. Now we've already proved the first thing that we needed to prove, that AB is equal to 2AM. And then next, in order to prove that AM is equal to 1/2 AB, you just have to divide 2 from both sides, which gives us the final answer. You should have gotten something similar to this or the exact same thing as this. If you did, then congratulations, you got it right. If you didn't, go back, rewind the video, and watch this over one more time. Okay, well, that's the end of the lesson, and I hope you guys found this video educational. If you did, leave a like, subscribe, and then come back for more educational videos like this.